Okay. My next guest is already with us. Oops, let's ready for the next session. And I'm just going to see if I can get that to come up. Just 1 second. And this is the next session, which is from the absolutely wonderful Bruno Fierens, or Bruno, you can correct my pronunciation when you come onto the live Q&A. But Bruno is very well known. He's from TMS Software. And this session, I saw a little sneak preview of some of this a couple of weeks ago. And I immediately contacted Bruno and said, you've got to show this on this AI camp that we're doing, because I was really blown away by it. I think TMS are always pushing the envelope on some of the things they do with the components. The TMS Web Core, great product, really like it. Many of the other things, most of you out there have probably used TMS components one way or another. If you're not using the all access library, then there's some other components you'll have used them, but they've got some great stuff. But this video is about an hour long, and then Bruno's joining me live afterwards for the Q&A. But I recommend you stick around for it, because it's going to blow your mind what you can do with Delphi. But we'll be back with the live Q&A shortly, so see you in a moment, about an hour.
Thank you for being here and attending this session at the AI Codecamp by Embarcadero and Ian Barker. And for today, we are going to talk about adding AI superpower to your Delphi applications, and did this with our upcoming product, TMS AI Studio. So on the agenda for today, what do we have? We will start by using LLMs from Delphi applications, so cloud hosted but also locally hosted LLMs that you can access from your Delphi applications programmatically. How you can do function calling from LLMs also from a Delphi application. And then we'll move on to the concept of creating AI agents, MCP servers to do so, how you can create a command line interface based MCP server with Delphi, and how you can also make a bridge or take advantage of an MCP bridge that we created for you to let your Delphi visual applications play the role as MCP server, meaning that an MCP client, cloud client for that, can be used to steer your application, automate your applications. In other words, do intelligent stuff with your applications. And we'll also cover the topic of creating your own MCP client, so that you can not only take advantage of your own MCP servers, but that you can also use other MCP servers created by other people and combine them together to work with your applications. And finally, we'll close with the availability of the tools that we have for you in the making. So I'm Bruno Fierens. I'm CEO, CTO of TMSsoftware.com, and it was my pleasure to work on AI tools in the past year or so, to overview, steer and develop myself using these new interesting technologies, and to present them here today during this webinar. What this webinar is about, in short, is about integrating AI in your Delphi applications, how you can build AI agents with Delphi, and how you can create agentic flows also with your Delphi applications, your Delphi code. What it is not about, that is how you can use AI to generate Delphi code, to improve Delphi code, all these things that help you develop Delphi code with AI. That is not the topic of this webinar for today. We are going to cover and look at how you can use LLMs, large language models, via a REST API and to do that from a Delphi applications. The LLMs that we are covering at this moment, the icons are shown here on this screen. And for those who are not familiar yet with these icons or logos, these are the names of the LLMs. OpenAI, ChatGPT is covered, Google's Gemini, the Grok LLM is also covered, the DeepSeek LLM, and then from Anthropic, the Claude, Perplexity is available, Olama, that is the LLM that you can also locally host on your machine, is also accessible via a REST API. And we conclude with the European-based LLM from Mistral. Basic functionality of accessing cloud LLMs via the REST API comes down to sending text, sending the context of your questions or of your tasks from different roles. In a nutshell, this is often referred to as the prompt. So basic functionality is sending your prompt and receiving the answer from the LLM. And typical use cases are translation of text, summarization of data, analysis of data, information retrieval. All these things can be done via LLM that is controlled via a REST API. What we will typically need to do for this is for the cloud LLM that we want to use, such as OpenAI's ChatGPT, Claude's from Anthropic, that is to get an API key to start using these cloud LLM based AI. Of course, that is not needed when you use a locally installed Olama, for example. Then you can start using the REST API right away. Next thing to do is to select the model that the LLM will be using to answer your prompts. And different cloud LLMs offer different models that you can choose from. And you will see that different models are fine-tuned to slightly different use cases. So it might be an advantage to select a specific model for your use case. And then when we have the API key ready, the model selected, then we typically set the context, the prompt that we want to submit to the LLM. And in a response to the HTTPS post of this prompt, we get a text response from the LLM. That is what the LLM answered us on this prompt. So technically, if we look at the code to achieve that, here you can see that we are using Claude from Anthropic that is selected in the FNC Cloud AI component with the service property. And you select the API key for Claude and also configure the Claude model that you want to use. We created our FNC Cloud AI component in such a way that it is completely abstract what cloud LLM you will be using. So you can use exactly the same code for different LLMs. Whether you want to use today Claude, tomorrow ChatGPT, and the day after Google's Gemini, the only thing here you will need to change is the service, of course, and set the proper API key. And by default, there is already always the latest model selected, but if you want to override that, you can do that via the settings and select the model. And then what we do is set the prompt, the context, here in this case with a question about a tool for creating Windows applications with RED component-based approach. And we also specify an additional item, the system role with the prompt, and that is that the LLM should answer us from the perspective of an IT expert. And then we perform the execute method of the Cloud AI component. And in response, we get the answer. Here is, for example, the text answer that was given back from the Cloud LLM with the different suggestions for Windows development tools. And the good news is that the first place was for Delphi from Embarcadero, of course. Next thing to do or to cover is discuss what can be done with LLMs with function calling. In the first case, we have spoken about sending your prompt and getting a text response back. What we can now do is inform the LLM that we have different functions that are available for calling by the LLM. So we actually instruct the large language model that we have a series of functions available that the LLM can call, and the LLM, when it considers some function that needs to be called, it will perform the call. In other words, it will return in its answer the function name that it wants to call with the parameters that it wants to call, and then it is the task of the handler of the function calling to return that response. An example use case here is to feed the LLM with live data. The LLM, of course, is built on a model that was built at some point in time with some information available at that time, but we want to augment the data that the Cloud LLM can use with, for example, function calling that can be used for that purpose. So how does that work technically? First of all is we inform the Cloud LLM about all the functions that we have available, that we give to the Cloud LLM with a description of these functions. And then everything starts with the user who sends a prompt to the LLM. The LLM identifies at that moment the function that it might have to call to give a proper answer on the prompt. So first thing is identification of the function. When a matching function is found, it will perform a call to that function. In other words, it will return the function name and the set of arguments or parameters the function needs to be called with. Then it is the task, in our case of the Delphi application, to execute this function call with these parameters and send the result back to the LLM. The LLM will get that result back and will then create its final answer and send that the generator response and send it back to the user. That is how function calling can be used from LLMs. And here is a code example how we actually implement that. So we have our Cloud AI component, and the functions here are represented by tools. So we set up the Cloud AI component, we add tools. Here, for example, a function call that gets the weather at some specific location. So we describe it by the description, get the weather for the specified city. The parameter of this function will then, of course, be the name of the city for which we want to get the weather. And we also give that parameter a description. That is the information that we provide to the LLM so that it can be smart enough to select the proper function to call and also to pass the expected parameter to that function. And here for that parameter we also inform the LLM that this is a text parameter. When the LLM identified the function, it will return that to our FNC Cloud AI component, and it is then the responsibility of our Cloud AI component to identify that function and actually execute that function. And that is done by launching the event handler to execute that tool and pass the parameters that the LLM sent to that function. You can see here that the parameters are passed as the args parameter, which is a JSON array actually of all possible parameters that are passed. We know, as we defined the function ourselves, that the first parameter is a string parameter containing the city name, so we can extract the city from these arguments, and then we call a API, a different REST API, to get the actual weather conditions at that specific city, and we return it as text. Here in this case, and we'll see it in a demo, we will return that text as a JSON object. So let's move to Delphi and dive into using the FNC Cloud AI component to work with cloud LLMs. So here we have Delphi 12.3 to be precise, and let's start with the basics, which is simple prompting and getting responses from an LLM. Here we have the Cloud AI component. I have a drop-down that is filled with all the LLMs that are available that can be used from our FNC Cloud AI component. As you can see here, we have the service property, and from this service property we can select what LLM we prefer to use. And basically, when I perform execute, as you can see, I'm setting the context with the prompt that I fill in the memo, and then I call the execute line. Also, when I change the combo box, then of course from there I will change the service of my Cloud AI component. There is not much more to it than this. That is also handling the event that is triggered from the Cloud AI component when the LLM has returned its response. And when that was a valid return, the HTTP status code will be 200. And in that case, we can fill the response in the second memo. If something went wrong, we simply show the HTTP error. Let's have a look at this example. I run this application. In this case, it is a VCL application. To note is that the FNC Cloud AI component is a component that can be used both in VCL but also cross-platform in FireMonkey applications. So here I can select my LLM, and here my question is, what is a good red native Windows software development tool and language? And let's see what Google's Gemini comes up with. It is waiting for the response, and here we see the different options, and of course we also see that Object Pascal Delphi is among the answers of Gemini. We can ask the same question to Mistral, for example, and I see here that our capacity is exceeded, so let's use DeepSeek, for example, and let's see what DeepSeek comes up with. And so in this way we can compare responses from different LLMs. It takes some time for DeepSeek to come up with a response. That might depend on the load of the LLM at that moment, might also depend a little bit on network conditions. And here we can see that DeepSeek returns for us as the number one option Delphi's Object Pascal for Windows application development. Let's move on now to function calling. And for function calling, here we have the demo that gets the weather at some specific city. So again, our Cloud AI component, but here we will be using the tools property to get the weather. So we added one tool. This has added only one function to be called, and this is the function get the weather for the specified city, and the function name is get weather. So that's that unique identifier that the Cloud LLM will send back to us. And if we have a look at the parameters, there is only one parameter necessary for this. It's a string parameter the description is the name of the city. Of course, that is all that there is to this. And we also need to have a look at the handler of the tool. So we go to tools again, that get weather function or tool, and this has the onExecute method. So when the LLM identifies that this function needs to be called, this onExecute event will be triggered. Let's have a look at the implementation. Well, we call the getWeather function, and I'll show you in a moment this implementation of the getWeather function. And the argument is, of course, the first argument, the name of the city. Here we implemented a function to get the actual current weather condition at some specific location. Here you can see that we use, first of all, the OpenStreetMap functionality to convert the name of the city into the geographic coordinate, the longitude and latitude of that city. And it is when we have that longitude and latitude successfully retrieved, which is happening here when I execute that request to OpenStreetMap. When I have that longitude and latitude, then I'm using another free REST API to get at some specific longitude and latitude the current weather temperature. And I'm asking here, the parameters that I'm asking is the current temperature and the current wind speed. And I'm executing that second REST API request to get these weather conditions. And when that response is successful, I'm getting some JSON back. Here you can see that I got the temperature and the wind speed, and I'm creating here the JSON response to that. The LLM will get that JSON response as a string. It is smart enough to figure out the different parts of the JSON, in other words, the temperature and the wind. So let's see when I run this application, and let's use OpenAI, for example, for this one. And let's ask the weather conditions of a city. And let's take the city of Rome in Italy. And let's see what OpenAI will be doing. We see already here in the output debug that it has triggered our function. And this is the function response. You can see the JSON here, and you can see that OpenAI was smart enough to extract this information from the JSON and return us this response in a nicely readable textual way. So easily human readable way. And we can, of course, do the same with other LLMs. Let's move another step further, where we have actually integrated this with our FNC Maps functionality. So here we added a couple of more functions to our Cloud AI component. We go to Tools to see what we have added. What we added here is a function to clear the markers on the map, a function to add a marker on the map. If we look at the parameters of that method to add a marker, we can see that the first parameter will be the longitude, so the name lon and the description, the coordinate longitude. The next one is the latitude, and then the third parameter is a title of that we add to the marker. So 3 parameters for the add marker function. In code, to make it a little bit clear how you can also programmatically add functions to the Cloud AI component, here you see that we also add another function. We repeat the function to call the weather, and then the parameters here in this case will be, or another method here is to add, and this is here, here we add a label with the weather information on the map. So other than a marker, we add a label, and that label contains the text. What we also did here is actually we made this function with an array parameter. So that means that if we request the weather for multiple locations, it will perform only one function call, but it will pass as an array the information to be added as labels on the map. So here we say the parameter type is an array, and within that array we can specify here through array properties that each item in that array should contain 3 further properties, that is longitude, latitude, and the weather condition at that position. So let's see how this works in action. And here is my application. We can use Claude and Trophic, for example, for this example. And I will add the following prompt. Show the weather for the following cities as a label on the map. And then I add, for example, London, Paris, and let's add also Brussels. And let's execute this with Claude. It is working at this moment, and here you can see that it already called the function with the city name London, Paris, and Brussels, and it collected this information. Let's zoom in a little bit to make that more clear. And here you can see that at the coordinate of London, that label was added as expected, and also for Brussels and for Paris. And so this is how you can do all kinds of things with function calling, and as such augment and let your applications be steered with natural language by using the LLM. Another example before turning into other data types that we can use with LLMs is actually how we can use natural language to execute queries on a data set. So here we have the Cloud AI components. Again, we have a look at tools. I have added 2 tools, and the first tool is to retrieve the fields that are available in my data set. The second tool is to set a SQL command to my, here in this case, ADO query component. So if we look at the implementation of get fields, you can see that I'm returning here a simple comma separated list of fields that are displayed in my grid. The second tool is the tool that sets the SQL, and here you can see that executing it is getting the first parameter, which is the SQL command, and set that SQL command to my query component and actually execute it. So let's see what this results in when I run this application. Here you see it's actually a FireMonkey cross-platform application. It's using our FNC data grid, and it shows here all kinds of airplanes that were built throughout history, and some information data about all these airplanes. And here in a natural language, I specify I want all planes that are not from the United States and that are built before 1970. So here you can see country, here you can see the year where it was built, and I added some additional helper information to get so, or to do so, get the fields in the table, planes, and then create a SQL command for a Microsoft Access table to get this result and execute this SQL statement. So that is a little bit guidance or steering for the LLM to ensure that it generates SQL that is, in this case, accepted by Access. So let's use OpenAI, for example. In this demo, I launch the Cloud AI component, and here you can see the SQL that was generated. So, here you can see how that SQL statement matches with the natural language specification that we gave to the Cloud LLM, and it executed that, and we see the result live in our data grid. So far we focused on textual prompts and getting textual information also with the help of function calling. Let's move now to the last thing that we can also do with the Cloud AI component, and that is what is called in AI terms multimodal use. So we can also send other types of data to the LLM and let it work on it. Here in this case, we have the Cloud AI component, and what we do here, I will show you the code that will make it clear. Here we give, in addition to the prompt, which is describe the picture, we actually add an image to that prompt. And so we actually add that image data type here in this case, and we ask the LLM to perform something on this image that is passed. So here we go a step further and we add additional information, and we ask the LLM to work on that additional information. So if I launch my application, here I can pick, for example, this classic painting, and I ask the LLM to describe that picture. Claude was here selected by default, and let's see what Claude comes up with, what it sees in this picture. You can see that it detected wine, fruit, a bottle of wine, it says so, and then some more description on that picture. It actually also seemed to identify the painter of that picture. If we use another LLM, let's use OpenAI for that and see how that LLM comes up with an answer. You see that the answer is quite different. And here it actually correctly identified something that is barely humanly visible, that it is indeed a bottle of champagne from Jules Bum. So you can see subtle differences in responses from different LLMs. What you can also do in this demo is, for example, add two images and ask the LLM to compare these two images to inform us about what's different. That's another thing that we can do with LLMs. Another example is that we can also send an image that contains text and ask the LLM to perform OCR on that image. But all these examples are available in the FNC Cloud Pack, so I leave that to you to play with it, to discover all this. Also, another type of multimodal use is by sending additional text, and this is also done with the add file method. Let me have a look where that is happening. Here we add, instead of an image, we can also add text files, for example, CSV files, to let the LLM perform analysis on these textual additional information that is added. So a lot of things you can do. I think how you can enrich your applications with Cloud LLM functionality. So let's move on with that covered to the next topic about MCP servers and clients. And here we are going to take it to the next step with introducing MCP servers and client. That is Model Context Protocol. That is what MCP stands for. and so the concept of MCP servers and MCP clients. We covered function calling from LLMs in the first examples. Now, what is MCP? Actually, MCP is a standardized way, a standard protocol with which you can create an application that will inform the LLM of the functions that are available, but also in addition to that, resources that are available, like image files or other file types. So everything that you want to give as context to the model can be encapsulated in a server application that will talk to a client, and the client will actually perform the communication with the LLM. So it is the task of the client to start the MCP server, to discover all the things that are available in the MCP server. So that is the functions, the resources, the prompt, and so on. And it will pass that information from multiple MCP servers that can be connected, pass that information to the LLM that is being used, and the LLM can take advantage of it and can enrich, augment responses with information retrieved via these MCP servers. And the nice thing about the concept of MCP is that this is a standard protocol. If you create an MCP server that implements this protocol, it will be able, you will be able to use that with any MCP client, and you can mix different MCP servers with your own MCP server to give to the LLM a total set of tools, functions, resources that are available to improve LLM responses. So how does that actually work? Here is the diagram. And so here we have the same question: what's the weather in a city, for example? And we are using here the MCP client, which is Claude Desktop. So there are different clients. Claude Desktop is one of them, but also, for example, Visual Studio Code or Cursor AI IDE have or function as MCP clients, which means that you can configure multiple MCP servers to be used with these tools. So here this focuses on Claude, but that is perfectly replaceable by something like Visual Studio Code, Cursor AI, Windsurf, and so on. So here the request is sent from the Claude Desktop, and that Claude Desktop will use its MCP client part to interrogate the different MCP servers configured with that Claude Desktop client, and return all or fetch all the tools, functions, resources available from the different MCP servers connected. And then it will inform the LLM about the functions that are available. And when the LLM detects that some specific function can help in generating its response, the first thing that the MCP client at that moment will do is show the user and ask the user a permission that that MCP server will be used to get the proper response to create a good answer from the LLM. And that is, of course, because the MCP server has, for example, full access to your machine. It can be a Delphi application, so you can imagine it can do whatever locally on that machine. So that's why, first of all, it will display a permission request before the actual function is being called from the MCP server. When the permission is granted, then the request will be executed. The MCP server can do whatever on your machine. For example, it could retrieve files, directory structures, it could add data to a database, etc. So when the permission is granted, function is executed by the MCP server. The MCP server does what it has implemented, returns the requested data, and that data is then sent back to the MCP client that will in turn inform the LLM about the data retrieved, and the LLM will enrich its response with the data retrieved and send it back to the user. So that's how the flow is of using MCP client and multiple MCP servers together with a LLM. At this moment, there are already several MCP clients available, and here I have the names of these clients. So Claude Desktop is such a client, Cursor AI IDE, as I explained, also Klein, Visual Studio Code, Windsurf, and with the classes that we developed, actually you can build your own Delphi client as well as Delphi server with directly from the Delphi IDE. I have also added 2 URLs where you can find a list of available MCP clients and available MCP servers. So as I explained, you can also mix and match. You can use whatever client with whatever MCP server. So if there is an interesting MCP server that you want to combine with the own Delphi MCP server that you created, you can do so. How you create this is done by the help of classes that we provide. And here you can see that the TTMS MCP server is created, and with this code here you can see that we in the second line we give the server a name and a version, and the next step will be to add tools to that MCP server, which you can see in the line here, server tools.add, with the add tool that comes on the next slide. So the add tool is where we tell our own MCP server what tools are available, what actually the MCP client, by means of the LLM, what tools it will be able to call. We give it a name, each tool, and also a description. Remember the function calling for LLMs, where this is the same concept. There's also this description here, and also the parameters, the arguments, which are described as properties. So here in this example for calling the actual weather conditions, that argument will be city, and we add some description and type of the parameter that is passed. And in addition, we also have the property that a parameter can be either required or not required. That information is sent to the LLM. The LLM will decide whether it will effectively then add this parameter when, for example, it would be marked as a not required parameter. And then, of course, the tools that we define for our server also need to be handled, of course. When the LLM decides so that this needs to be called, and when it is granted to call it, then this will be triggered, and the handler executes that. Here in this case, as you can see, again, the arguments are passed through this handler, and here we get the first argument, which was the city name, and we call the weather API, return the result via the MCP server. So let's have a look at demos with which this will become even more clear. Here we have our first example, which is actually the MCP version of the first demo that I showed you with the FNC Cloud AI component function calling, but here created as a MCP server. So what we have here is we create and code the MCP server, we set the version, and then we actually add the tool. Here we add it, and here we have our get weather tool that is added and the parameter that is added for it. So that's the tool that we create, and here we add it to our server, and we can add as many tools as we want to this server. Then of course we need to have a look at the handler. So here the handle weather tool, this is where the function that is called when our LLM needs it. And you can see here that I'm grabbing the first argument. Actually, if it does not pass arguments, which it shouldn't do, but just in case, we set it to a default city. We get the weather with actually the exact same function as with the function calling demo. And here you see how the result is returned. Now, how do we use that MCP server? Well, we simply compile it and it creates a Windows command line application. And here I will do this demonstration with the Claude desktop. And in the Claude desktop, when we go to settings in developer tab, you can see here that I already added 4 different MCP servers. So this is the basic one, database demo, the MCP bridge, and also an external, not written by us, MCP server for accessing Spotify. In Claude, this is actually configured by a JSON file. So you can see here that this contains the place where our MCP executable is located. Here you can see that you can also pass arguments to these executables. And here you can see an external one, which is in this case an application built with Node. And so that's how in Claude you configure the different MCP servers. So let's have a look by using Claude now and adding our prompt. Please give me the weather, and we will ask the weather for Madrid. And command is launched and it is invoking the Claude LLM right now, and you can see here that it detected that it should call the get weather function that we defined and pass the parameters. So, and you can also see the response from our MCP server. And you can see here the nicely formatted response from Claude. Another example that we created was an MCP server that can be used to work with databases. So what we have here is the MCP server that uses a FireDAC connection. You can see here that it's a FireDAC connection to a SQLite file. And you can see here the different functions that are added. Here it is configuration. It supports FireDAC, so you can use all the databases that FireDAC supports. And let's have a look. Here you can see the configuration of our MCP server by adding different tools. So here we have a tool to run a query, to get all the tables from a database, to get the metadata of tables, to actually create a table in our database. So here you can see all the different functions that are available for our database. And you can see that it contains all the necessary tools to completely work with our database. Retrieve data, create tables, add data, modify data. All these things are possible with this database demo. And if I would execute it from here, show a list of tables in my database. Let's have a look here you can see that it identified to get the tables, to call that tool get tables, and here you can see the tables that it finds in our database, the SQLite database that we configured. And here, for example, we can say give the fields of the table clients of customers in our database, and let's see what it comes up with. Get table info is the function to be called, and here you can see the actual metadata for our table that was retrieved. And so not only that, but you could retrieve the actual data, you could let the LLM perform data manipulation, and so on. And with that, I think we are ready for the next part, which is about MCP clients. So where in the previous demo we showed the Claude desktop MCP client to work with the MCP servers that we created from Delphi, here we are going to introduce the MCP client that you can develop with Delphi itself. So you're not longer needed to use an external MCP client tool. You can build your own tools. And the nice thing is, first of all, this is offered by a non-visual TMS MCP client component that has all the functionality built in. And of course, that MCP client can take advantage or can use your own Delphi created MCP servers, but in addition, also any other MCP server, any server that actually is compatible with the MCP official protocol can be used from our MCP client, where the Claude desktop tool is of course configured to use the Claude LLM from Anthropic. Here our MCP client can be configured to use the LLM of your choice, and that could include OpenAI's ChatGPT, that could include the locally running Olama, etc. So let's have a look at that demo in Delphi. And here we have our client demo, and the central piece actually is our TTMS MCP client components. And you can see that non-visual component here on a data module. You can see that you can configure the multiple MCP servers that you want to let the MCP client work with via this collection property. But we wrapped everything into a demo where we have, first of all, our own FNC chat component to interact with the LLM. You can see here that we can choose the LLM of our choice. And you can see from here, it will become clear when we run the application, that you can perform the settings, that is, give the information on all the MCP servers that you want the client to work with from that dialog. So running this application will make it more clear right away. And so here is our demo. Let's first have a look at settings. Here you can see that the exact same MCP servers have been set as we had set for the Claude desktop. So everything that you can do with Claude, you can also do with our own MCP client. Interesting here is, for example, for the weather MCP server, you can inspect here the functions available in that tool. The database MCP has a number more tools, and so these are listed here. And so you can add, of course, new MCP servers, add extra arguments that might be needed. All that is available for you. What I want to show in this demo is actually taking advantage of the MCP bridge that we created. I explained that when you create an MCP server, it is a command line tool, and that of course limits what can be done. So what we also offer is a bridge, and a bridge is a command line tool that will actually work with a visual Delphi application, and that allows you to use an MCP client with the bridge server to connect to a visual application, so that from the MCP client you can actually from externally from that client steer whatever needs to happen in your application. So what I will do here is the following: add Delphi function to sort an array of strings and set that function in my editor. And here we are using actually OpenAI to do that for us. So our bridge is actually configured to work with the server part that is here in our visual Delphi application that uses our FNC memo with syntax highlighting, and you can see that OpenAI created a sorting function for us, and it added that with the instruction set that function in my editor. It set it in the editor automatically for us. And we can do more. We can also retrieve that text from the editor, do something with it, and then, for example, update it in the editor. So what I'm going to do is the following. Add an XML, I do different, get the function from my editor, add an XML comment describing that function, and add everything together back into my editor. That is the instruction that I'm giving to OpenAI. So let's see what is happening. It should actually, and as you can see, it did so, decorate my sort function with an XML comment. And that shows you how you can not only use that bridge with a server part that is integrated in a visual application, but also how you can steer all that out of our own MCP client. Let that work with whatever. If, for example, I would ask here, give the weather conditions in, for example, Lisbon, of course, it will decide to use the other Delphi MCP server that we created for retrieving the weather. And you can see the current weather in Lisbon is 21 degrees. So it picks the MCP server that is configured here under settings and allows you to do whatever you want to do. And with that, we are concluding this webinar. I hope you find this very interesting. Let me add the information where you can start playing with it. At this moment, we are in a test version. And so that test version, we make it available for free to all active TMS All Access users. It can be used at this moment from any Delphi 11 or 12 version, and when it's ready for release, when we have gathered all your feedback, polished everything, documented everything, created all the demos that we want to pack, it will be available as a TMS AI Studio product. And you can also from there indicate your interest in this product, apply for a test version, and you can also give all your comments and feedback. Or what you can already do now, the first part that if you do not have TMS All Access, what you can already do now is get the FNC Cloud Pack. Even the fully functional free trial version can be used for that, to do everything with abstract handling of cloud LLMs and function calling together with LLMs. So we invite you to participate in this exciting new chapter at TMS involved with AI. We are very excited with all the possibilities that open up for us Delphi developers. So we welcome all your feedback. It's very helpful, instrumental in shaping the things the way you want it and the way you want to take advantage of it. We have a special email address for any concerns in this AI direction, and that's simply ai@tmssoftware.com. Thanks for your attention, and if you have further questions, let's move to the Q&A section.
Fantastic. That's the second time I've seen a lot of that. Maybe the third time. I think I saw it in Amsterdam as well, actually. But the good news is we do have Bruno with us live on the Q&A. Hey, Bruno, how's it going?
Hello, Ian. Everything's fine. Thank you. How are you?
I'm good. Yes, yeah. I've recovered from my flights from Amsterdam, so it's always a bit of a. I love going there, but those flights are a long way if you live over here. I first saw you do a very short demo of your AI stuff before, and I think it was like the week before the Delphi Summit, so a couple of weeks ago. And I remember emailing you saying, "This is amazing. This is really fantastic." And I honestly mean that. I mean, I like your component. You know, I'm a fan of your components anyway. I like WebCore, for example, and many of the others I've used personally over the years. But these ones, for example, the MCP server and client is a real game changer, I think. I think that you've really embraced the moment in terms of AI. So good job from you guys. And is that actually released now, or is it still like a beta? Or I didn't quite catch what was happening.
At this moment, it's still a test version. What you see, what I actually demonstrated was the MCP server and client using STDIO for communication, which is what is at this time still most used with MCP. But the MCP specification says that there's also the possibility to use SSE and streamable HTTP.
Wow.
And that is actually what we are now also finishing, so that you can also call remote MCP servers. For example, an editor like Cursor AI offers also to bind MCP servers over streamable HTTP SSE. And so that's because I personally think that MCP over HTTP will also become very attractive. Then you can actually offer something like MCP as a service. You don't have to host it yourself. You can give it access to data that is hosted somewhere else. So I think a lot of interesting possibilities open up. And that's the last piece of the MCP specification that we are finishing.
Yeah, I really think it's exciting. I think as always, you're ahead of the curve with these components. But they're FNC, right? So they're cross-platform. Is that right?
They are cross-platform, yes.
Yeah. So for those that don't know, and they must be living under a rock if they don't know by now about the FNC components, but they allow people to write them for Windows, for Mac, for Linux, for iOS, and Android, and the web as well. And
there is for the web there. There is
okay.
something important to mention here. You will understand that the access of the cloud LLMs, the OpenAI and Mistral, etc., all require an API key.
Yeah.
And it would be a very bad practice to make that key visible in a web application. That's why it is not supported to use it in a web client.
Right.
You should
Yeah.
actually, I think, the proper place to use it is in a backend.
Yeah, so they could use some kind of they could either use web broker or something, or Xdata or Aurelius server in the background as well, and do it that way. There you go. See, I know all your stuff. But I think that I mean, there are lots of different server technologies. This is one of the benefits of Delphi, of course, is its strength is that back end, and then whatever the front end is, if they choose to do it in some other web language, fine. But you're opening up that communication for MCP. That's what excites me. I find that a real step forward, because I think what happens then is people are able to write apps that can actually be controlled by AI in a really profound sort of way. I think that it's a bit like being able to say, "Hey Alexa, send an email," but actually it could be any of your programs, and it's not Alexa; it's Claude or whatever other AI they choose. But you've also added, the ability to be a server on the end as well. So I think it's great. I really like the demo. You're very good at finding the right pace for the demo as well, and covering it thoroughly. A couple of people say, "Oh, it's a bit quiet." We will fix the replay. It was still, I found it perfectly okay, but some people are, "Oh, it's a bit quiet." But I'll boost the volume for the replay so they can, that will avoid them complaining. What we've got some questions here, but I don't think they relate to that. There, a lot of chat from two particular people. A guy called Skybuck Flying. I don't know what that's about. And Maxi Donkey were just having a long conversation about MCP and things like that, and I don't know, the blockchain and everything. But um, a whole bunch of people stuck it out to the end to watch the demo. So I think that's a good thing. And I put the TMS QR code. This goes directly to the website, and then they can look at your components. Okay, all right. Well, thanks a lot, Bruno. Any
You're
final
welcome.
words from you at the end? Or I think you pretty much covered it, but
Yes, this is, I think these are exciting times. And
yeah,
I would say let's embrace AI to make our Delphi applications even more powerful and also steerable via natural language, which is the other side, then using AI to generate Delphi code or improve Delphi code, find issues with Delphi code. So my opinion is let's embrace it for every aspect of our
that,
development, and enrich our applications.
yeah. I mean, that is actually a very good point. That a lot of people, when they talk to me about AI, they're like, "Oh, AI generating code or fixing code or finding bugs." But I think that's I mean, it's a good focus, but I think it's only a very small part of what is happening to the world in terms of AI. This is I can't, if I'm an old guy, I've seen it all when it comes to technology. I mean, I think I'm actually older than you, with respect,
I think
yeah,
it will be close.
yeah. You're a young whippersnapper, but anyway, um, uh, but I have seen almost everything, every big step in the computer industry for 40 or 50 years. My father was a director of ICL, so I saw it when I was a kid as well. And this to me is one of the most exciting step forwards that has happened for generations. And I really think that Delphi programmers have got an opportunity here to embrace it and be ahead of other people, because I think that some of the strengths of what Rad Studio does and Delphi does can actually really help propel us even more. I mean, Stack Overflow's survey describes Rad Studio as a rising technology. I don't know whether you're aware of that, but their survey that's on at the moment describes Rad Studio as rising. Nobody said that about Delphi and Rad Studio for years. In fact, usually the opposite. Oh, are people still using it? So I think if we all take a reasoned, seasoned look at what's happening, and embrace it for what it can do, and not be scared, but be cautious and be, sensible about the use of it. I think it is an amazing opportunity. I'm very excited. I'm glad I'm alive to see this new era. But I think it's as important as the internet, the PC, all of those things, maybe more so. I don't think I'm quite as crazy as Elon Musk, who said it's more, is the most dangerous thing since the atomic bomb or something. But yeah, it's a good thing. It's a good thing.
Actually, talking about the other side, use it for helping us with development. Tomorrow, I'm hosting a webinar on TMS Web Core, and actually there I'm showing how to use an LLM AI to generate HTML, CSS for you to actually make nice forms with just natural description of what you want to get. I mention it because this evening I was preparing the last bits and pieces of the webinar, and I was amazed myself with
What can be done?
just generate it and use it. It's incredible.
Yeah, my session on Monday, I showed basically how you could reproduce the functionality of Google Translate in a few lines of code, and I actually got most of the web pages designed using AI. I didn't do that. I mean, I can design in HTML, but I used the AI to do it, and that was the hardest part, was getting the HTML right so that it looked like Google Translate. The easy part was making Delphi do all the translation, automated AI translation. That's the stupid thing. You'd think that'd be the hard bit, but actually it was the easy part. It was, getting HTML. So I think they should probably look at your webinar and join along and see, you've got some useful tips, and I will make sure I catch a recording of it, because I think I'm going to be busy doing other things tomorrow.
We'll have the replay, no problem. We always record it and make
Yeah.
the replay on YouTube.
Of course. All right. Well, it's good to talk to you again, and we'll probably bump into each other in some event somewhere, I'm sure. But until then, thanks a lot, Bruno. Cheers.
All right, Ian, thanks for having me. Until the next time. Bye bye.
No worries. Speak to you soon. Cheers.